I hope we all know what a public IP is and private IP. You know, public IPs are IPs that are routable on the internet. Private IPs are not routable on the internet. So when you're talking about the 172.0.0.2.172.31.255.255, this is a private class B. Private class B. We also have 192.168.0.0 to 192.168.255.255. This is also private class C. Then we have 10.0.0.0 to 10.255.255.255. This is also private class A. These IP ranges are not routable on the internet. They are meant to be used internally. All other IPs are public. Public IPs have to be registered. You can have access to public IP addresses from an internet service provider, ISP. They will grant you access to public IP addresses. So let's look at this topology. Let's take a look at this topology of a certain company. So the company have their network like this. And their servers or PCs are connected this way. This is the local area network of that company. So every IP here will use the private IP range, be it the class A, class B, or class C private IP. And when you want the connection to the internet, then you contact your internet service provider, and your internet service provider will provide a public IP for you. This interface, which connects to your ISP, this interface now becomes public. If it's public, it means this interface alone can be accessed from anywhere. So let's assume your ISP gives you 11.0.0 and .0/30. You are going to configure 11.0.0.1. At your end, it's a public IP. Then your ISP will also configure 11.0.0.2 at their end. With this public IP, anyone on the internet can just open a command prompt and ping 11.0.0.1 and it will respond. It will respond. Let's try it. Let's try it. I'm coming to ping a certain public IP. So pick up the command prompt. And I'm pinging CNN.com. It's responding. You see, that is their public IP. 151.101.65.67. There's a DNS server that resolved this domain name to an IP address. And that's their public IP. You see, it's accessible everywhere. See where I'm sitting. Awoshi Market. And I'm accessing a public IP. So, supposing this end here is, this company is a CNN.com or CNN. I'm pinging up to, and that is me here. I'm having connection all the way to this interface. But over here, I will not have any connection because it's a private IP address. Now, talking about VPN, VPN is a technology that will grant you access to their private network over the internet. You see, so the connection that I just made is pinging. I just did that over the internet because I have internet connection and I was able to ping CNN.com. But I did that up to this level here, their public end. I couldn't enter their network. And as I said, VPN is a technology that will give us access to a private network. We have different types of VPN technologies. We have different types of VPN technologies. You can talk about site-to-site VPN. You can talk about remote access VPN. You can talk about SSL VPN. There are more, but these are the popular ones. Today we are going to learn site-to-site VPN. And what is site-to-site VPN? Before I talk about site-to-site VPN, let me talk about remote access VPN. Remote access VPN is this company here has a connection to the ISP or the internet. And the company has a staff who is a teleworker. A teleworker means somebody who can work from anywhere on his laptop. So supposing you are home in the house with your laptop, but mind you, you should have an internet connection. And there's a task that has to be done by you inside your network. Let's say on this server, or you will need to work on this router because you are a network engineer. There's a problem with this router, you need to configure it. You need a VPN access. And this type of VPN is called the remote access VPN, okay? For a single user who has an internet connection coming all the way from the internet inside a private network over the public internet. It's a remote access VPN. What about the site-to-site VPN? If you talk about site-to-site VPN, then you're talking about two companies. So let me add another company here. So this is company one, CNN. And let's assume there is another company here. Also with a private network over here. Now on a normal day, a PC in this private network should never have a connection to a PC in somebody's company, private. It doesn't work that way. It will never work. But with site-to-site VPN configured on both companies' routers, now you are granting access for the private computers here to communicate. So supposing this PC or this network is 192.168.1.0/24, and over here you have 172.16.1.0/24. They are both private IP addresses. The only means by which you can make them communicate is to configure site-to-site VPN. And this configuration is done on the head-end routers. If I say the head-end routers, what I mean is these routers here and that. These are the head-end or the perimeter routers or your last mile routers. That's where I'm going to configure the site-to-site VPN. Remember, this end of the company is also public. Please, is there any question somebody wants to ask? We should go on. Are you there? Please let me hear from you. Are you there?
Yeah, yes.
Okay.
Yes, we are here.
And I'm sure that
I want to record.
Yes, we are here.
Okay.
Can I be granted access to
recording
record?
anyway. I'm recording anyway, so if you don't mind, after I've recorded, you can copy.
Yes,
What do you think?
it's okay.
All right. Now, before we do the configurations, we have to understand the technicality of VPN technology. Because after the configuration, I always say that configuration is a piece of cake, but your understanding will help you to troubleshoot a problem, if any. So let's understand the technology very well. Okay. This VPN we are coming to configure is called the IPsecVPN. First of all, what is IPsec? What is IPsec? Okay, IPsec is a security protocol stack. It's a security protocol stack. VPN itself poses a security issue. Okay, because you are moving from your private network all the way to the public internet to another private network. Like this and like that. This is a very harsh environment. The public network, there are a lot of hackers, a lot of things happen there. So that's what I mean by VPN being a security issue. But you still want to go. So you need a very tight, a very strong security. And that strong security, IPsec is the one that will provide it for you. In talking about security, you need confidentiality. Confidentiality. You also need data integrity. You also need authentication. Now, what is confidentiality? Confidentiality, as the name implies, the document has to be confidential. It has to be meant for an intended recipient. So it's only the intended recipient who should have access to the document or the connection they are making. And, you know, in IT, everything is protocol. Protocol is a set of rules that make things happen. So if you want confidentiality, of course, it's a set of rules. Somebody will sit back and write down some code, protocol, program that will ensure that confidentiality. And the protocol that ensures this confidentiality is something that will encrypt your data. So anytime you talk about confidentiality, you should think of data encryption. Okay, you need to encrypt that data encryption. That is about confidentiality. And what are the protocols that are responsible for encryption? Okay, we have several protocols that do that. You can talk about AES, You can also talk about 3, D, E, S. All of them are protocols. You can talk about R, S, A. All these are codes, different types of protocols that will encrypt your data to ensure confidentiality. So the beautiful thing is you don't need to learn the coding that is entailed in these protocols. You only have to know the name. Suppose I ask you which vehicle can take you from Ghana to London. The vehicle is an aeroplane. You know it. You don't need to be a pilot. Somebody was telling me that, a student was telling me that IPsec is too difficult. I asked him why. He says, now you have to know all these protocols, AES. Come on. Just know their names. That's all. You don't need to know any technicalities. This AES, the full meaning is Advanced Encryption Standard. So if you Google, you want to know more about how many places? AES. Yes. I was giving you something else. Okay. So Advanced Encryption Standard Algorithm. At least it will give you something to read on. It will give you something to read on. So this AES, we have different standards of AES. Let's check. This thing is this is not what we need. Let me get something lighter. Okay, so AES, it says the features of AES are as follows. Something, and you come here. You can have AES 128-bit, you can have AES 192-bit, and AES 256-bit. Okay, what I'm trying to do is, if you want to read something on AES, you can, but you don't have to go into detail. So this AES, we can have 128 bits, we can have 192 bits, we can have 256. You see, the higher the number, the stronger the encryption. So AES 128 bits will not be as strong as AES 192, followed by AES 256. So this one is the strongest. So if you are encrypting and you need a very strong encryption algorithm, you can choose AES 256 bit. Same way we have 3DES. Okay, it's also an encryption standard. And the differences are there. RSA, they're all there. You can read about them. What about data integrity? So the message which is still moving on the internet, you want integrity. Integrity is I'm sending X amount of packets. I need X amount of packets to be sent to the recipient. Integrity. Everything that you send must be received exactly as it is. So aside encrypting the message that you are sending, you want to be sure that you are sending, the receiver is receiving exactly what you are sending. And the protocol that will do the job for you is SHA. SHA. This, you have to look for it's an acronym. I know it's the names of the people who came up with the algorithm, SHA. We have SHA-1, we have SHA-2, and so on and so forth. So this is also an algorithm that does data integrity. We also have an algorithm called the MD5. It also does algorithm. So what I would recommend you do is just read something light, okay, something light on the protocol. You only have to understand that for data integrity, these are the protocols that do the job. For confidentiality, when we're talking about encryption, these are the protocols, and even more. What about authentication? Now, the data that you are sending, when it gets to the recipient, there has to be some sort of verification. Are you really the recipient? So you need to enter some level of password. Okay, yes, password. So anytime you talk about authentication, you think about password. And the different types of authentication that we have IP, extensible authentication protocol. We have PIP. We have CHAP. We have PAP. We also have something called pre-share. Pre-share. Pre-share, the name is full self-explanatory. So this is the protocol that we are actually going to use for the side-to-side VPN. I'll explain when we get there. All these are authentication protocols. Challenge handshake authentication protocol, password authentication protocol, extensible authentication protocol. The P I've forgotten, but it's something extensible. It's an enhancement to the IP. It's an enhancement to the IP. So you can go and read on that. So take note, the point here is all what you need in ensuring security is CIA. CIA, as in Criminal Investigation of America. CIA, take note. You need confidentiality, that is encryption. You need data integrity. These are the protocols that ensure data integrity, and you need authentication. Any question, please? Any question? Okay, so we are still explaining IPsec. IPsec is a stack of protocol. IPsec is a stack of protocol stack. So in one protocol, you can have confidentiality, you can have data integrity, you can also have authentication. So inside this IPsec, there are all the protocols that will do confidentiality for you. You have them there. AES, blah, 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 they're all there. Integrity, SHA-1, SHA-2, they're all there. Okay, it's just like you know, the people who sell medicine in pharmacies. One medicine can cure about 10 diseases. I hope you're aware. One medicine can cure about 10 diseases. So if you pick one pill, it can cure blood pressure. The same medicine can cure diabetes. The same medicine can cure corona. The same, I mean, everything is inside. So that is how we can relate IPsec. It has all the tools inside it that can ensure good security measure from end to end. So now with IPsec explained, let's talk about site-to-site VPN. But before we talk about site-to-site VPN, I need to explain some protocols. I need to explain some protocols. Supposing we have this simple network here. And a simple connection. There is no VPN. Now PC A and PC B want to communicate. PC A has an IP address of 1.1.1 and .1. And PC B has 2.2.2.2. They want to communicate. Data will be encapsulated. So the payload itself is here. The payload is here. Layer 4 will encapsulate. With source port number and destination port number. Layer 3 will also encapsulate with source IP and destination IP. You know this already. Then layer 2 will do that with source MAC address, destination MAC address, and the packet is ready. You say that this packet is a raw data. It's unprotected, very raw. Anybody can intercept this packet anywhere and read whatever is inside it. So if you want to ensure a certain level of security, then you have to do certain encapsulation. And the best protocol you can use for this encapsulation are two. We have the ESP and we have the AH. The ESP is, I think it's encapsulation security payload. ESP, encapsulation security payload. And this is also called authentication header. These two protocols can help this data that you are sending to be protected. How do they do that? Let's take ESP for instance. ESP can do that in two different modes. So the first mode is for the transport mode. And the second mode is called the channel mode. In fact, both of them can do that. AH can also do it in the transport mode and in the channel mode. What is the transport mode? What is the channel mode? So if, for instance, ESP is to protect this data here in the transport mode, what ESP will do is it's going to insert. Please, somebody should shut down somebody has to mute. What ESP is going to do is going to insert a header inside here. It's going to separate, divide this into two, like you want to spread margarine inside bread. Then now the whole packet now becomes something like this. We'll go off very soon, but don't get bored. If you go off, we'll log back on. So that's the layer 3. layer 4, and the payload. Source port, destination port, source IP, and destination IP. All right, let's go back. Let's go off and come back. Okay, our 40 minutes is up. Don't go away. I'm disconnecting and reconnecting.